All right, so let's look at the review for Calculus Quiz 4.2 to 4.5. So the first thing we want to be able to do is find the linear approximation of f of x is equal to the square root of x, add x is equal to 4. All right, so the equation that we're going to use for that is literally just our point slope form. So it's y minus y1 is equal to m times x minus x1. They just write the y1 over here. So instead of y minus y1 on the left, you can see they've just added the y1 over here on the right. So this would just be y1 plus the slope times x minus x1. So I'm going to need a point and I'm going to need a slope. So they asked me to find this at the value x is equal to 4. They didn't give me a y value, but if I put 4 in the place of x, then that would just be the square root of 4, which would be 2. So there's my ordered pair, 4, 2. Then I need a slope, and remember that slope is just derivative. So if this is the square root of x, that's x to the 1/2. So the derivative of that is going to be 1/2 x to the negative 1/2. You also could write that as 1 over 2 square roots of x if you like that better. And so we are supposed to find the slope of the tangent line at 4. So let's go ahead and put 4 in for x. So if we put 4 in the place of that x right there, then we will get 1 over 2 times 2, or 1/4. So now I have a point, 4, 2. I have my slope, 1/4. And so I can come over here and I can say y minus y1, so here's my y1, plus m times x minus x1. So again, I'm just plugging in my point, my x value of 4, my y value of 2, and my slope of 1/4. All right, then it asks us to use that to approximate and estimate the square root of 3.9. All right, so all we need to do then is just put 3.9 in the place of x. So if we come over here and we put 3.9 in the place of x, 3.9 minus 4.0 is just going to give us a negative 0.1, or a negative 1/10. So 1/4 times 1/10 is going to give us 1/40, so negative 1/40. And if I have 2 minus 1/40, then that would give me 1 39/40, or 1.975. And just so that we can see that really is a good approximation, if you take the square root of 3.9 on your calculator, this is what you get. So yes, that is an excellent approximation. All right, then for number 2, they ask us to find the differential dy. All right, remember, for a differential, you literally are taking the derivative dy dx and treating it like a fraction. And so if we would say that dy dx is equal to the derivative, then if we multiply both sides of that by dx, then the definition of the differential dy is just the derivative times dx. So that's where it comes from, so that we don't have to memorize it. So literally all I'm going to do is take my derivative and then multiply it by dx. So if this is my original function, my derivative of that would be 3x squared plus 4x minus 7. So 3x squared plus 4x minus 7 times the differential dx. So dy is equal to the derivative times dx. Then they give me specific values to plug in. So they tell me to put in 2 for x and 0.1 for dx. All right, so if I put in this formula right here, if I put in 2 for x, and 0.1 for dx, then that's what you can see right here. So 3 times 2 squared plus 4 times 2 minus 7, and then we're going to multiply that by 0.1 for dx. So order of operations, I'm going to have 4 times 3, which is 12. 12 and 8 is 20. Minus 7 is going to give us 13. And so 13 times 0.1 would be 1.3. All right, then for number 3, they ask us to find the critical numbers for this function. Now remember that your critical numbers are anywhere that your derivative equals 0 or that your derivative doesn't exist. So the first thing I need to do is find my derivative. I'm going to use chain rule, because anything to the negative 2, the derivative of that would be negative 2, that thing to the negative 3. And then we're going to multiply by the derivative of that thing, the derivative of the inside. So the derivative of x squared is 2x, and the derivative of 2x is 2. So here's derivative of outside, and here's derivative of inside. So let's clean that up a little bit. So we've got negative 2 times 2x plus 2 in the numerator, and then we've got that x squared plus 2x to the third down in the denominator. So there's my derivative. Your critical numbers are going to be where your derivative equals 0 or where your derivative doesn't exist. The only way a fraction equals 0 is if its numerator equals 0. So this derivative will equal 0 where the numerator is equal to 0. The only place this derivative doesn't exist is what's not in its domain. Your domain is going to be all real numbers unless one of two things happens. You have a fraction or a radical. I have a fraction. So we're going to say that our denominator cannot be equal to 0. So where the derivative doesn't exist is where the denominator equals 0. So when I look at where my numerator equals 0, I've got negative 2 times 2x plus 2. So let's set each of those equal to 0. Negative 2 equals 0 doesn't exist, so we'll toss that. 2x plus 2 is equal to 0. If we subtract 2 from both sides and then divide by 2, then we'll get x is equal to negative 1. So there's one critical number. And then when we set the denominator equal to 0, for this guy right here, let's take the cube root of both sides. So that leaves us with x squared plus 2x is equal to 0. When you're factoring, we always take out our greatest common factor, so we could take out an x, and that would leave us with x plus 2. So set each of those equal to 0, x is equal to 0, and x plus 2 equals 0, so that would give us x is equal to negative 2. So those would be my three critical numbers. All right, then for number 4, they ask us to find the absolute maximum of this function over the closed interval negative 3 to 3. If you have a closed interval, you will always be able to find an absolute maximum and minimum. It could occur at a relative maximum or minimum, or it could occur at an endpoint. So first, we need to locate our relative maximums and minimums, and that comes from our critical numbers. So let's take our function and let's find our critical numbers. So again, critical numbers are just where the derivative equals 0. So if we take the derivative of this, that's going to be 12x to the third minus 12x squared minus 24x plus 0. So here's my derivative. I'm going to set it equal to 0 and solve it. So to solve, the first thing I'm going to do is take out my greatest common factor of 12x, and that would leave me with x squared minus x minus 2. Set each of those equal to 0, so I'll set 12x equal to 0, and that'll give me x equals 0. For the x squared minus x minus 2, I could factor that down a little bit further. So that would factor to x minus 2, x plus 1. So if I set each of those equal to 0, if x minus 2 equals 0, I get x equals 2. And if x plus 1 equals 0, I get x equals negative 1. So those are my three critical numbers. So I'm going to plug those in to my original function because I'm looking for values on the original, maximum and minimum on the original. So I'm going to take 0, 2, and negative 1 and plug them back into this original function right here to find their y values. All right, so when I do, I get 6, negative 26, and 1. Then I also need to plug in my endpoints. So my endpoints were 3 and negative 3. So I'm going to take those and plug those back in as well. So I'm going to plug 3 into the function and I get 33. Plug negative 3 into the function and I get 249. So out of all of these y values, the absolute highest one is 249 and the absolute lowest one is negative 26. So this is my absolute maximum and this is my absolute minimum. Now, something for your quiz tomorrow is I will not on the quiz give you something like the ordered pair 0, 6 and the ordered pair 0, 26 and the ordered pair 0, 86. The ordered pair that I give you, the y value will go with that x value. Because I know that's the time-consuming part is for you to have to sit here and plug in each one of these x values to find your y value. So the ordered pair that I give you will be accurate. You won't have to plug 2 in to find out if it really is negative 26. Now, I might give you the ordered pair 0, 6 and the ordered pair 1 whatever goes with it, and 2 whatever goes with it, and -2 whatever goes with it. I might give you extra values that were not critical numbers. So you can't just look at the answers and go, oh, which is the lowest and which is the highest. You do still need to find your critical numbers and your endpoints to see which values you want to see what's the maximum and the minimum. All right, then for number 5, for the function on the interval -1 to 1, would the hypotheses of Rolle's theorem prove true? So first off, I need to know what those are. Number 1, the function has to be continuous on the closed interval, differentiable on the open interval, and f of a has got to equal f of b. All right, so let's start with the first one. If I am looking at my original function, remember that I'm going to have to look at anywhere the function does not exist, where it might have a hole in it. All right, so where this function doesn't exist is just its domain. The denominator cannot equal 0. So this is going to exist everywhere except for at 0. It's undefined at x equals 0. Well, 0 is in that interval, so no, it's not continuous on that interval. Now, if the interval had been from 1 to 2, that would have been fine because 0 would not have been in that interval. All right, if you instead had looked at the differentiability, if you take the derivative of x to the -2, that would be -2x to the -3, or -2 over x cubed. And so if you're looking at the domain of that derivative, it also does not exist at 0. So it is not differentiable at 0, and that is in your open interval. So you may have said that Rolle's failed because it was not differentiable at 0, and that would be fine as well. The only thing you could not tell me here is that f of a did not equal f of b, because when you plug in -1 and +1, you do get the same value for those. All right, then for number 6, they ask us to verify the hypotheses of the mean value theorem, and if we could do so, then to go ahead and find all of the values C that would satisfy the conclusions of the mean value theorem on that interval from 0 to 2. So we have a polynomial on the interval from 0 to 2. So the first hypothesis, is it continuous from 0 to 2? Well, yes, because all polynomials are continuous everywhere. Is it differentiable on the interval from 0 to 2? Yes, because polynomials are differentiable everywhere. But the other thing you could do is actually take the derivative. And when you take the derivative, you get 1 plus 2x. And in looking at that, you can see there's nowhere that derivative has a fraction or a radical. So there's nowhere it's not going to exist. So yes, it's differentiable everywhere. So since my hypotheses are true, then I can go ahead and use the mean value theorem, which just says that the derivative will be equal to the slope at some point. You also could multiply both sides of that by b minus a and write it this way. So it does not matter which way you write it, which way you use it, you're going to get the same thing. So now I'm going to need my derivative, and I'm going to need y2 minus y1 over x2 minus x1. So all they gave me was x1 and y1. They gave me x1 and x2. I'm going to need to plug in 0 into the function. So when I do, I'll get 1. So that's my first ordered pair, 0, 1. There's x1 and there's y1. And then I'm going to plug 2 into the function. So 1 plus 2 plus 4 is going to give me 7. So there's my next ordered pair. There's x2, y2. So when I go to find my slope, I can say 7 minus 1 over 2 minus 0. So that's what you see right here, 7 minus 1 over 2 minus 0. I'm going to set that equal to the derivative. So now let's go find our derivative. So the derivative of 1 is 0, the derivative of x is 1, and the derivative of x squared is 2x. So there's my derivative right there, 2x plus 1. They just use a c in the function instead of x. All right, so 7 minus 1 is 6, over 2 is 3, so we just want to know where 2c plus 1 equals 3. So subtract 1 from both sides, divide by 2, and c will be equal to 1. And I just need to check and make sure that that is within my interval, and sure enough, that is in the interval from 0 to 2.